Students, we are going to learn about vector addition. Now, when we deal about addition or subtraction, we at least need two quantities to add, or it can be more than two but cannot be less than two. Alright, if we are going to deal with vector addition, then we need at least two vector quantities, and it should be same vector quantity. So we can add two forces together. So both the forces are vector quantities and it is one quantity only. So you cannot add velocity and force together because both are different quantities. Okay, so for vector addition the quantities should be same, but we need two different values, I would say. Okay, so before we learn about vector addition, let us first see what is a vector quantity. A vector quantity is defined by its magnitude as well as direction. Now we already know that magnitude is a number or a value, and direction is represented by an arrow, that in which direction you are moving, whether it is moving towards east or the force is applied in a left direction or right direction. So those quantities are called as vector quantities. Now either you can pictorially show that how vector looks. So pictorially representation will be like this, that if I have to show that there is a force of 500 Newton, then I cannot fit 500 centimeter line on this paper. So I have to scale down this number. So I can take scale as 1 centimeter is equal to 100 Newton. So then 500 Newton will be 5 centimeter. So I can draw a 5 centimeter line which will represent a magnitude, and this will be 5 centimeter which represents 500 Newton force. And if the force is moving towards right, so 500 Newton force is applied in a right side direction. So we show an arrow which is pointing towards right side direction. So this is a pictorial representation. But if we don't want to show it pictorially, then by looking at the value also we can understand what is the magnitude of the force as well as direction. So there is a convention which is used to understand even when there is no picture at all. So let us see what is that convention. So let us first understand about the horizontal motion. So horizontal motion means what? It deals with either left or right side. This is the horizontal direction. Okay, so horizontal direction will be either left or right. So which convention is used for left and right? Let us understand. When the vector is pointing towards right side, it is always represented by a plus sign, and a vector when it is pointing towards left side, it is represented by a negative sign. Okay, so you don't need to represent it by showing an arrow. Even if, for example, if the vector is given like this, that the force value is minus 400 Newton, the actual force we cannot apply minus 400 Newton force. Okay, it is not having negative value. But what does this negative sign represent? It represents that this force is pointing towards left direction and the value of that force is 400 Newton. Okay, actually we cannot apply minus 400 Newton force. Okay, so this minus sign has conventionally is been representing that it is in pointing towards left. All right, and when it is pointing towards right, you just write down plus sign in front of that magnitude. All right, and if when there is vertical motion, in vertical motion when the vector is pointing upward, that time it is represented by plus sign, and when the vector is pointing downward, that time it is represented by minus sign. Okay, so upward is represented by plus sign and downward is represented by minus sign. So if, for example, if the vector is given only for vertical motion, all right, for vertical motion they will specify either it will be just horizontal motion or vertical motion. They cannot give both together because then the signs will get mixed up. So when there is only vertical motion, and if the vector represented is as minus 300 Newton, then minus sign represents that the vector is pointing towards downward direction. Alright, and the magnitude is 300 Newton. So you have to pictorially, it can be seen like downward pointing arrow, and that arrow has magnitude minus 300 Newton. Alright, so if we take some examples of vector addition, now we are here for vector addition going to consider two vectors, because for addition we need two quantities. So here you can see the first vector is pointing towards right hand side and it has value 5. So it can be anything 5. It can be 5 Newton, or if it is velocity, it can be 5 meter per second, or if it is acceleration, because even acceleration is a vector quantity, it can be 5 meter per second square. So your only value is given. Depending on which quantity is there, we can write down the unit. Okay, so this vector is pointing towards right side, that's why in bracket it has plus sign, and there is one more vector which is pointing again towards left side, so there is plus sign. So plus 5, when we add together we get plus 10. So when there is plus sign in front of 10, that means what, the vector is moving in a right side direction. So this is the resultant vector. Alright. So when you add two vectors, that time you get a resultant vector, and of that resultant vector you have to specify two properties. One will be magnitude and another will be direction. Okay, and both the things are specified over here. The direction is towards the right and the magnitude is 10. Okay, and depending on the quantity you can write down the unit. If it is force, then you can write down 10 Newton. Then the next example is one vector is pointing towards right and other vector is pointing towards left. When it is pointing towards right, we have to take plus sign, and when it is pointing towards left, we have to take minus sign. So plus 5 minus 5 will give you 0, and that's why we do not have any vector over here. Now let us take third example. One vector is pointing towards right and one vector is again, another vector is pointing again towards right. Okay, but only difference is in magnitude. This vector is a small vector which has only 5 value, and this vector is a 10 value, is having 10 value. So plus and plus, because both are moving towards right hand side, both will have sign convention as plus. So plus 5 plus 10 is going to give us plus 15, and the direction is going to be right hand side because it has plus sign. Next example, first vector is pointing towards right hand side, that's why it will have plus sign, and second vector is pointing towards left hand side, that's why it will have minus sign. So plus 5 minus 10 will give us minus 5. Alright, and because it has minus sign, that's why we have to draw arrow in the left hand side direction. Okay, so it will point towards left. Next is plus 5 and minus 15. One is towards right and other is towards left. So one is going to be positive, other is going to be negative, and plus 5 minus 15 is going to give us minus 10. Because here it is minus, it is going to point towards left hand side direction. And this was with respect to horizontal vector addition. Similar way, we have vertical vector addition as well. So if both the arrows are pointing upward, upward always has sign convention as plus plus. So plus 5 is going to give us plus 10, and this arrow is going to be little bit greater in length. Why? Because 10 is having higher value than the 5. Okay, and if we have like this, like plus 5 and minus 10, plus 5 means the arrow is going upward, and minus 10 means the arrow is going downward. So plus 5 minus 10 will give us minus 5, and this minus sign represents that the arrow is going downward. So resultant force or resultant vector in this case will have magnitude as 5 and direction pointing downward. Alright, so that is how the sign convention of vector addition works.